Hello everybody. Welcome to my session on the cutting-edge tools that will revolutionize indoor planning. Today, I am going to discuss some business challenges that need indoor planning, different types of indoor planning and tools. I will discuss and demonstrate how GIS can revolutionize indoor planning. There will be 3 demos in this session before we conclude the sessions. There are many challenges in this social distancing era. Organizations are asking, can we keep people in our workplace safe? Is there a plan in place to manage and reconfigure the facilities to meet social distancing requirements? There may be guidelines to follow or even government mandates. Organization needs a clear picture on nature of work and where work needs to be done. The COVID-19 has also brought concerns into workplace in many aspects. One of these is to be able to trace where people came into close contact with one another, or where and how long people have spent time at each location in the workplace. And finally, all the information such as floor plan, location of assets, people, incidents, work orders, need to be brought into a common view or common operating picture. To deal with those challenges, we need indoor planning. There are many types of indoor planning. These are just some examples. As there are quite a bit of indoor planning to do in a short time during the crisis, existing tools like paper floor plans, CAD drawings, or spreadsheet applications are no longer adequate. Each organization needs to plan holistically with reduced workspace capacity, starting from the individual workspaces, offices, common areas on each floor in each building. The plan also needs to cover the entire campus or site. As working from home policy is being adopted widely, vacant spaces need to be repurposed to maximize the benefit over cost. For instances, rental, lighting, temperature control, cleaning, etc. Various scenarios based on factors like nature of work, floor plan layout, traffic circulation patterns may have to be considered and planned out in order to select the best one. For the day-to-day operations, the tool to help plan and manage workspaces is also needed. For example, reserving meeting rooms, seat assignments for work area, office hoteling for occupancy rotations, usage monitoring, sanitization scheduling. Tools also need to support emergency responses, mitigation, evacuations, or contact tracing. ArcGIS Indoors has been developed to help support various indoor planning and operations as shown in this slide. I would like to show the first demo created by an Esri team in Redlands and presented by Maya O'Brien.
Hello everyone, my name is Maya O'Brien, and in this demo I'll walk through how you can visualize social distancing analysis on an indoor map, develop space plans that meet social distancing requirements, and allow employees to reserve safe workspaces when they come back to the office. We'll start by looking at the Indoor Viewer, a web application that lets you visualize data for your facilities on indoor floor plan maps. These maps give you a central system of record for your facilities. Here, I'm looking at a map of the Esri campus. By selecting a specific building, I can get an interior view of the floor plan. I can toggle between floors and see every office and cubicle in the building. The Indoor Viewer can also incorporate other types of data. For example, you can use analysis tools in ArcGIS Pro to analyze social distancing parameters, then visualize the results in the viewer. Here, we've generated a 6-foot buffer around open cubicles in the marketing wing, shown in blue. This represents the minimum social distancing zone needed for employees to safely occupy each cubicle. We've also highlighted areas where these zones overlap, shown in red. This lets us see which cubicles have social distancing conflicts. Using these results from the social distancing analysis, we can make decisions about how to reassign employees to make sure everyone has a safe workspace. To do this, we'll use Indoor Space Planner, a web application that lets you use indoor maps and data to visualize and manage space use throughout your facilities. Like the indoor viewer, I can bring the results of my analysis into Space Planner to help develop space plans that support social distancing. By highlighting the area above these cubicle clusters, I can see that I have a number of employees assigned to spaces with social distancing conflicts that I'll want to reassign to meet safety guidelines. I'll start by unassigning these individuals from their cubicles. I then can start to quickly reassign employees to make sure there's only one person per cubicle cluster. I can do this by dragging and dropping their names onto the desired cubicles in the map. In a short time, I can have a space plan that will allow these employees to maintain physical distance from their colleagues. In some cases, social distancing guidelines may require us to operate at less than our typical maximum workspace capacity. One way we can accommodate this is by setting aside safe offices and cubicles as office hotels that employees can reserve on days they need to be in the office. Next week, all of our marketing employees are going to move to a staggered schedule. Many of these employees were assigned to conflicting cubicles, so we'll need to provide them with other workspace arrangements. We'll do this by creating an office hotel. By selecting Add, I can create a new hotel area. Next, we can select every cubicle in this wing and assign them all to our marketing office hotel. Then, to ensure our employees only reserve the safest cubicles, keeping in mind our social distancing analysis data, we can add or remove cubicles from the office hotel as needed. By doing this, we've identified a set of 8 cubicles that our marketing team can reserve when they come into work. Now, let's take a look at the experience of reserving a workspace in an office hotel. By using the ArcGIS Indoors mobile application, a member of our marketing team can quickly find and reserve an office hotel in a few simple steps. First, they'll tap the hotel button, where they can specify desired dates, space type, as well as hotel area. This will provide a list of all available offices that meet that description. Second, they'll select an office, and the app will zoom to the office location. Third, they'll select Book and confirm the booking details. The reservation will be confirmed with an email, and they'll be ready to come back to work. In 3 steps, they reserve their safe workspace. Lastly, if need be, they can also reserve a conference room directly from the ArcGIS Indoors mobile application. By quickly locating a conference room and selecting Schedule, they can view conference room availability and add a new calendar event. The app syncs the appointment with their Outlook calendar, reserving the conference room and notifying all attendees of the meeting. In this demo, we analyzed our office space to understand social distancing conflicts. We then resolved these conflicts in the Indoor Space Planner, and then walked through the experience of an employee reserving a safe workspace in preparation for returning to the office.
In the demo you just saw, it showed ArcGIS Indoors application and some of its functionality specific to indoor space planning. We use the GIS approach to revolutionize indoor planning by using geospatial data model. We developed and evolved indoors information models to support real-time and historical indoor mappings and analytics. We use big data store technologies to keep records of large data to support temporal analytics such as contact tracing. We also use an evolved indoor positioning system that helps identify precise locations indoor, where GPS is mostly not reliable. ArcGIS Indoor consists of new and existing ArcGIS components. The technology stack is built around the components on the list here. This slide provides a quick overview of functionality each component provides, how all the components of the technologies are being used. Let's look at the next slide. This diagram shows the data flow from the IoT sensors that provide primary data for calculating indoor positions on the left, to the real-time processing and analytics platform in the middle, and finally to the user-facing applications such as maps and dashboards on the right. Many IoT hardware are available on the market today. The technology is evolving rapidly. New hardware components have been introduced every few months. Different hardware technologies provide different aspects on accuracy, deployment, maintenance, cost, and etc. When putting all the components together, this is how it may look like. ArcGIS Indoors provides an indoor GIS for making smart buildings or workplaces. It introduces the indoor information models and indoor positioning that supports the operations below. The indoor information models allows storing of objects' properties, categories, and their relationships within the indoor hierarchy, ranging from offices to floor to buildings and sites. These are the components included with ArcGIS Indoors. Let's look at a demo on asset tracking by Mo Siddiqui.
You're looking at a web map in an enterprise portal viewer. In this web map, I have added ArcGIS Indoors floor plan layers for a site, and it has facilities, levels, units, and other indoor layers. I've also added wheelchair geo-event streaming service, which is showing live wheelchair tracking on the map. To view the floor plan, I'll now uncheck the facility layer to hide the shell. This facility has 3 floors in it, and you are viewing the footprint for all the levels in this facility. You can see the live feed for the wheelchair and its changing locations. This map is showing all the wheelchair's assets irrespective of what floor they are on. We can visualize the wheelchair assets in ArcGIS Indoors Viewer app for each floor at a time using a floor filter widget. Let's take a look. You're now looking at ArcGIS Indoors Viewer app, which I have configured to use the web map we saw earlier in the portal viewer. In order to view floor plan and floor-specific wheelchair, I need to click on the facility, which is going to remove the outer shell. On the top right corner, you can see the floor picker widget appear once I clicked on the facility. The widget is now active, and it gives me an option to switch between floor 1 and 3. You're now looking at the live wheelchair tracking on floor 1 of this facility. I can also identify these streaming services by clicking on them and view the attributes. You can see this wheelchair is located on first floor, and my floor picker is also active on the first floor. I will now switch between floor and will only see floor plan, points of interest, and wheelchair for the selected floors. I can control the visibility of the layer using this widget. I'll now enable the last known location layer for the wheelchair. We're now seeing wheelchair on the second floor. I can click on them to open info card and make use of Indoors capability. If I want to navigate to this wheelchair, I can click on the directions and enter the source location for Indoor routing. It generates the direction using the Indoor network analysis service. I can also switch my direction type to wheelchair to avoid stairs. If I want to explore all wheelchair assets and view the asset listing, I can go to Explore and click on the wheelchair category. To enable this experience, I have configured Asset Feature Service as Indoors category while authoring my web map in ArcGIS Pro. This is showing complete list of wheelchairs in your facility. You can click on these wheelchair assets to locate and highlight them on the map and open the info card. I have currently set the device ID as the display field, but if you want, you can change them while you are curating the map. I have also configured my wheelchair asset last known location on a web scene. Let's take a look in 3D. Like we saw in 2D maps, I can click on these facility shells to see the floor plan layout. The floor plan with 3 distinct levels are now visible. You can also see wheelchair assets on their respective floor. I'm now going to switch between floors and view one floor at a time. You can see the correct elevation for the wheelchair assets with respect to the floor plan. Like in 2D map, I can also identify these features by clicking on them. Take a look at the level to make sure our wheelchair is located on the right floor. Closing the floor picker will unselect the facility and display the shell back.
The next demo is about using GeoEvent and ArcGIS Indoor information model to do contact tracing. Since I am working from home, I asked my daughter Pam to help narrate it.
This is a contact tracing demo that uses the same indoors information model as the one for space planning and management. GeoEvent can be used to take the input from devices such as smartphones. The input data includes locations based on an indoor positioning system. The indoor positioning system can be implemented using IoT technology. GeoEvent provides many processors to compose real-time processing logic as shown in the diagram here. The real-time processing in this case is for the 6-foot proximity detection and logging. The results from the detection are output to a feature service backend. We can use the incident detector to detect when the distance between any 2 people are within the 6-foot threshold. The incident detector provides the start, the end, and the time span of the incident. We can identify the people involved in the incident using GeoTagger. GeoTagger uses a 6-foot buffer around the location of each input to perform dynamic geofencing. Other processors downstream in the processing pipeline help eliminate self-intersection. We use the field mapper to map the data into a more user-friendly schema before outputting to a feature service of a data store backend. This feature service stores all of the incidents over time and will be used for contact tracing when needed. The generation of the 6-foot buffer is done on a separate real-time processing pipeline as shown here. The results are output to a stream service to use for dynamic geofencing in the processing pipeline shown previously. On the mapping front end, we can see workers moving around on the map. A red circle encompassing each point shows the 6-foot buffer. I will refresh the map and zoom in a little bit closer on a location to show more details. When a circle around a person intersects with the location of another individual, a proximity incident is detected in real time and the result is logged as a feature in the database. We can use the operation dashboard to create a custom view containing maps and widgets as desired. Using ArcGIS JavaScript API, we developed a simple contact tracing application. The application takes the name of the infected person and the time window as inputs from the user. Let me scroll down on the list of people in this workplace to find the name of the infected person. Next, I will select the start and end date for the affected time window. I can also enter another parameter for the desired trace levels and start the contact tracing process. It performs query recursively on the incident database and provides contact results that can be displayed on a map, a 3D scene, as a list on a table, or as a contact tree diagram.
We have seen demos how ArcGIS Indoors work together with other components of ArcGIS, such as GeoEvent, Enterprise, Web Map, Dashboard, ArcGIS Developer, in this case JavaScript API. Putting these together can provide solutions for various domains such as schools and universities. Hospitals. Airports. These are just a small set of samples. In conclusions, using the GIS approach, the ArcGIS suite of products provides cutting-edge tools for indoor planning, workspace management, usage monitoring, asset tracking, emergency responses such as evacuation, and contact tracing. This will help organizations provide safe and secure facilities for workers and visitors in the social distancing era. Thank you.